You see a shadow glide across the sandy ocean floor. It looks like a spaceship, or maybe an ancient slow-motion bird beneath the surface. It's majestic, utterly mesmerizing, and carries a legendary and often grossly misunderstood defense mechanism that commands respect. We're talking about the stingray, and beneath that iconic flattened body lies a creature of truly staggering evolutionary design. Forget the reputation, forget the drama. This is the secret life of the ocean's gentle glider, a true master of camouflage, silent hunting, and biological innovation. To truly understand the stingray, we have to start with its foundation, its structure. As close cousins to sharks, they are classified as batoids, and the key feature of this entire group is their skeleton. It's made entirely of cartilage, the same flexible, durable material found in your own nose and earlobes. This isn't just a quirky fact. This lightweight, flexible structure is essential for their entire mode of existence. It allows them to develop the wide, flat, aerodynamic disc-like shape that defines them while remaining agile. This expansive shape is the engine of their propulsion. They rely very little on their tail for power. Instead, they move almost entirely with their enormous pectoral fins, which stretch out like wings and seamlessly fuse with their head. This graceful movement breaks down into two distinct categories. For the bottom dwellers in shallow bays and estuaries, we see undulation, creating a stunning, continuous wave motion that passes down the edge of their body. This subtle movement is perfect for gliding low and stealthily over the seabed. For those adapted to faster, more open ocean environments, they use oscillation, dramatically flapping their fins up and down, much like a bird's wings or a manta ray. They don't swim like a typical fish. They truly look like they are flying underwater. Furthermore, their skin is often covered in tiny, tooth-like scales called dermal denticles, which help reduce drag, keeping their movement effortlessly silent and efficient as they glide through the current. Their flat shape provides perfect camouflage, but it demands an extraordinary sensory system. Because they are classic bottom dwellers, spending much of their time resting or hunting buried in sand, and because their eyes are on top while their mouth is underneath, they cannot visually locate buried prey. This leads us to their phenomenal sixth sense, electroreception. Distributed primarily around their snout and head region are dozens of tiny, almost invisible, jelly-filled pores called the ampullae of Lorenzini. These are not just simple sensors, they are biological masterpieces. The canals are incredibly sensitive, allowing the stingray to detect the minute, incredibly faint electrical fields, often measured in billionths of a volt, generated by the muscle contractions and nervous systems of hidden, living prey such as clams, small fish, and marine worms. They don't just find food, they literally sense life under the seabed. It's the ultimate high-tech, internal metal detector for biological matter, and their sensory prowess goes even further. While hunting, they use a lateral line system, a row of sensory cells along their body that detects minute water vibrations and pressure changes, alerting them to nearby movement. For long-distance travel, scientists strongly suspect stingrays utilize magnetoreception, the ability to detect and orient themselves using the Earth's geomagnetic field. Given that many stingray populations undertake complex multi-hundred-mile seasonal migrations to find warmer breeding or feeding grounds, this internal compass is likely the secret to their precise, large-scale movements across the featureless ocean floor. Stingrays are strict carnivores, highly effective ambush predators specializing in hard-shelled diets. Their hunting sequence is fascinating. Once they pinpoint a meal using electroreception, they employ a brilliant technique known as tenting. With their large pectoral fins pressed firmly against the substrate, they quickly raise the front edge of their head, creating a momentary, strong vacuum. This powerful suction force instantly vacuums the hidden prey, shell and all, out of the sand and underneath their body. Their lower jaws are then brought to bear. Instead of the jagged teeth, typical of some sharks, stingrays possess specialized pavement dentition, rows of flattened, tightly packed, plate-like structures. These are perfectly adapted for crushing the hard exoskeletons of crabs or the tough calcium shells of oysters and clams. Like their shark relatives, these crushing plates are constantly shed and replaced throughout their lifetime, ensuring they always have fresh, sharp tools for the job. And now, the breathing dilemma when buried. When hunting or hiding from predators like the specialized hammerhead shark, the stingray's mouth is completely obstructed by sand or mud. This is where their ingenious spiracles, two small, prominent breathing holes located just behind the eyes, come into play. They act like snorkels, drawing in clean, oxygenated water from above the sediment. This water is then passed internally over the gills before being expelled, allowing the ray to remain perfectly camouflaged and motionless, ready to strike or stay hidden, without ever risking a mouthful of sand. It is a flawless adaptation for a benthic lifestyle. Beyond their physical traits, stingrays employ a deeply invested reproductive strategy. They do not scatter eggs into the water. Stingrays are ovoviviparous, a strategy that places a huge energy investment into a small number of offspring. The eggs develop internally, safe within the mother's body. The embryos are initially nourished by a yolk sac, but in many species, the mother secretes a nutrient-rich fluid, sometimes called uterine milk, to feed the developing young until birth. After a gestation period, which can be quite long, the mother gives birth to fully formed baby stingrays, called pups. Born relatively large, they are immediately independent. They can swim, hunt, and deploy their defensive mechanisms right away, requiring zero parental care. This evolutionary choice, investing heavily in a few well-developed young, ensures the highest chance of survival for the next generation. A stark contrast to the millions of small, vulnerable eggs produced by many bony fish. Furthermore, stingrays can sometimes exhibit complex social behavior, gathering in enormous groups, or fevers during migration or mating seasons. And finally, the infamous feature that gives them their name, the sting. Let us be absolutely clear. This is purely a defensive weapon, never used to hunt or attack prey. The tail itself can be long and whip-like, and embedded on its upper surface is the barb, a sharp, hard spine, often serrated with backward-pointing teeth. It's actually a modified dermal denticle, and rays can periodically shed and regrow these, sometimes temporarily having two barbs at once.